Welcome, folks. I wanted to give an introduction to cyclic groups and subgroups. So let G be a group and let A be an element in that group. We'll define the cyclic subgroup generated by A. I'm going to underline that because that's what I'm defining. We denote it like this, A with braces on either side. And it's the set of all things of the form A times itself K times, where K is an integer. Okay, so that's the definition. But if I wanted to, be a little bit nicer to you, I would say, it's all things of the form A negative 2, A negative 1, identity, A squared, A cubed, etc. Right? So A is just A to the first power, so K is 1. A squared is just A to the second power. The identity is actually always A to the 0th power. So it's sort of just notation, but any element in a group, when you multiply it by itself 0 times, you combine 0 copies of A with itself, you just get the identity. A to the negative first power is notation for the inverse of A. And then A to the negative second power is just take the inverse of A and multiply it, that inverse by the inverse. Square the inverse, multiply the inverse by itself. All right, so let's do an example. Maybe we let G be the integers and let A be 2. So the cyclic subgroup generated by 2 is I'm going to start with this. So we have the identity, which is 0. We have 2 combined with itself once, which is just 2. And we have the inverse of 2, which is negative 2. Here we have 2 combined with itself twice, but our operation is addition in this group. So this is 2 plus 2, or 4. And we have negative 2 combined with itself twice. So we have negative 4. And let's keep going. A combined with itself under addition 3 times is 2 plus 2 plus 2, which is 6. And then we have negative 2 combined with itself 3 times. Negative 2 plus negative 2 plus negative 2 is negative 6. So addition is the operation here. So in additive notation, A is just A squared is A plus A cubed is A plus A plus A, etc. And the cyclic subgroup generated by 5, for example, is just all powers of 5. So negative 15, negative 10, negative 5, 0, 5, 10, 15. Okay, let me do 2 more examples for you. What if my group is Z mod 6Z, and I take A to be 4? Okay, so the cyclic subgroup generated by 4. All right, let me just start with 4. That's this guy. I could have started with the identity, but I'll just start with 4. Now let's combine 4 with itself. So 4 plus 4 is 8, but mod 6, that's 2. Right? Now let's combine 4 with itself 3 times. Well, 4 plus 4 was already 2. So when I want to add 4 again, I just add 4 to 2. And I get 4 plus 2, which is 6. But mod 6, that's 0. And then from there repeats. So 4 combined with itself 4 times. Well, 4 combined with itself 3 times was 0. So when I add 4 a fourth time, I just get back to 4. So it's like this was 4 with itself once. This was 4 combined with itself twice, mod 6. This was 4 combined with itself 3 times, which mod 6 was 0. And then where was 4 combined with itself 4 times? Right here. We just keep hopping around to these different elements as you add more copies of 4. So 2 is also going to be 4 combined with itself 5 times. All right. And then our final example, I'll just say out loud. Pretend we have this group of symmetries of the square in 3D. So we have 4 rotations and we have 4 flips, okay? If I look at the cyclic subgroup generated just by this 90-degree rotation, that cyclic subgroup has 4 elements: the identity, this rotation, and that rotation, okay? So in this group of 8 elements, I found a cyclic subgroup generated by this 90-degree rotation that has 4 elements. I could also find a cyclic subgroup that has 2 elements when I take the cyclic subgroup generated by the 180-degree rotation. Because when I take the 180-degree rotation, the subgroup that generates has only 2 elements, the identity and the 180-degree rotation. Because when I rotate by 180 degrees twice, I just get back to the identity. All right, public questions? Thanks so much.